This video presentation is brought to you by the Pro Mathematics Academy. Welcome to another video presentation brought to you by the Pro Mathematics Academy. In this video, we'll be looking at implicit differentiation, which we define as the process of finding the gradient function or derivative as a function of both x and y. One of the most important rules we want to remember when performing implicit differentiation is that we have to multiply by dy dx whenever we differentiate with respect to y. That is, the d dx of f of y is equal to f prime y times dy dx. This video will be working by example, so without further ado, we jump right into question number 1, which says find the derivative given the following equation. ln xy plus the square root of x plus the square root of y equals 0. Before doing any differentiation, we want to remember our rules of logarithms, which says that ln of x times y is equal to ln of x plus ln of y. This means our equation then simplifies out to ln x plus ln y plus the square root of x plus the square root of y equals 0, which then we can apply our derivative operator to each and every term throughout the expression. This then gives us d dx ln x plus d dx ln y plus d dx square root of x plus d dx square root of y equals d dx of 0, which then turns out to be 1 over x, which is the derivative of ln x, plus 1 over y dy dx, which is the derivative of ln y, plus 1 over 2 square root x, which is the derivative of square root of x, plus 1 over 2 square root y times dy dx, which is the derivative of the square root of y, equals 0, the derivative of 0, which then simplifies down to 1 over y dy dx plus 1 over 2 square root y dy dx equals negative 1 over x minus 1 over 2 square root y. Factoring out dy dx out of the expression on the left then gives us dy dx times 1 over y plus 1 over 2 square root y equals negative 1 over x minus 1 over 2 square root of y. We then transpose for dy dx, which gives us dy dx equals negative 1 over x minus 1 over 2 square root y, all divided by 1 over y plus 1 over 2 square root y, and that is our answer. Moving right along to question number 2, we have find dy dx given the following equation: y squared plus xy minus 7x equals 4 tan of y. The first thing we want to do to our equation is we want to apply the derivative operator to each term in the equation, which then gives us d dx of y squared plus d dx of xy minus d dx of 7x equals d dx of 4 tan y. We then end up with 2y times dy dx, which is the derivative of y squared, plus x dy dx plus y times 1, which is the derivative of xy. We have to perform the product rule, and the product rule says that we have the first times the derivative of the second plus the second times the derivative of the first. The derivative of 7x is 7, and the derivative of 4 tan y is 4 sec squared y times dy dx. Always remember to multiply by dy dx when you're differentiating a term involving y. Now, dy dx times 2y plus x, grouping the dy dx is there, plus y minus 7 equals 4 sec squared y times dy dx. And now we bring over dy dx from the right hand side along with 4 sec squared, which gives us dy dx times 2y plus x minus 4 sec squared y times dy dx equals 7 minus y, which then we can factor out dy dx out of the left hand side expression. This then gives us dy dx times 2y plus x minus 4 sec squared y equals 7 minus y. Then we transpose for dy dx, giving us dy dx equals 7 minus y divided by 2y plus x minus 4 sec squared y. And that is our final answer. We then jump right into question number 3, right? And here we recognize that we also have to use the product rule again. So applying d dx to each term throughout the equation, this gives us d dx of x cubed y squared plus d dx of the square root of y equals d dx cos 2x plus d dx e to the y. We then perform the product rule on the first term, which gives us the first, which is x cubed, plus 2y dy dx, which is the derivative of the second, plus y squared, which is the second, times 3x squared, which is the derivative of the first, plus 1 over 2 square root of y times dy dx, which is the derivative of the square root of y, equals negative 2 sine 2x, the derivative of cos 2x, plus e to the y times dy dx, which is the derivative of e to the y, which then allows us to factor out in our next line dy dx from terms that have dy dx multiplying them. This then gives us dy dx times x cubed plus 1 divided by 2 square root y minus e to the y equals minus 2 sine 2x minus y squared 3x squared. We then transpose for dy dx, which gives us dy dx equals minus 2 sine 2x minus y squared 3x squared, all divided by x cubed plus 1 divided by 2 square root of y minus e to the y. And that is our final answer. That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.